All right, guys, so today we are going to be talking about graphing sine and cosine, but we're going to be doing it using real life context, real situations. All right, so with the warm up, should be pretty straightforward. If completely still water yields the equilibrium point of y equals 0, then y equals -5 cosine pi over 6x models a buoy bobbing up and down in the water. What that is saying is that completely still water, so if it's well, that's not a straight line. If it is if it is completely still, then it would be a straight line, and it's just saying that's equilibrium, where that's going to be your baseline, where that's going to be the midline. Okay, because anything above and below would be equally above and equally below it. So you have that water that would be the equilibrium point, and then the buoy would be going up and down on that water. So basically, just saying that as the water has the waves, the buoy is going to be going up and down on the waves. So something along the lines of if I have the wave, I have that, then you've got some sort of buoy that is on the water and just kind of going up. And now it's not going to go down below quite like that. So I guess I probably should have drawn a little bit differently, but that's kind of the gist of what it's saying here. Okay. Um, all right. So right here, what is the maximum height of the buoy? Well, maximum height of the buoy is going to be 5 feet. Sorry, I'm just noticing like it doesn't actually have a measurement on it, so we're just gonna say 5. I don't know if it's feet, meters. I have no idea. Um, inches. Then what is the minimum height of the buoy? Then it would be -5. And then what is the period of the motion of the buoy? Okay, so remember, period here is 2 pi divided by b. 2 pi divided by b. Question is what is b? Remember, b is the thing that is inside the trig function. So here's cosine. So it's immediately behind cosine, and it's being multiplied by the x. Now, if there was anything being added or subtracted inside parentheses, then I'd have to factor out, but I don't need to do that here. Okay? So I have 2 pi over b. So that's going to be 2 pi divided by pi over 6. And so when I do that, I do keep, change, flip. So that's going to get me 2 pi times 6 over pi, which is going to cancel out the pi's. And then I'm just going to be left with 12. Okay. And then what is the height of the buoy at 7 seconds? So I guess we're kind of assuming here, because this is missing some information, we're assuming that time is unilaterally here in seconds. So we're going to have to assume the height at 7 seconds would be when I set my equation equal, or not equal to it, but equal to it. Just that's going to be your input because that's your time. Remember, time on this would be that buoy is going up and down as time increases and its height is going up and down. So the height would be the output value. The time would be the horizontal. So that's the input. That's that x value. So what is the height of the buoy at 7 seconds? So that would be, I just take the equation that I was given right there in the original problem, -5 times the cosine of pi over 6. And then that pi over 6 gets multiplied by the 7 because it's no longer x. We're inputting 7 right here in the equation. So that gets me -5 times cosine 7 pi over 6. That actually could be something that I could do without a calculator. 7 pi over 6. That's going to be in my third quadrant. That's going to be the first pi over 6 just beyond pi. And cosine there is going to be -√3 over 2. So I have -5 times -√3 over 2. And when I multiply that out, I end up with a positive 5√3 over 2. 5 root 2. And that would be the height of the buoy at 7 seconds. You could also give that to me as a decimal, but I prefer exact. Yeah. A lot about graphing sinusoidal functions, but what type of scenarios produce these functions? Well, the types of scenarios are going to basically be things that are periodic, things that have constant back and forth repetition. So something that's swinging side to side, going in round motion, very repetitive kinds of motions, things like that. Uh, all of those kinds of things can be done by a sinusoidal function. So right here, it says that we have the giant wheel at Cedar Point is a circle with diameter 128 feet, which sits on an 8-foot tall platform, making its overall height 136 feet. It completes one revolution every 60 seconds. Assuming that the riders are on the edge of the circle, find a sinusoid which describes the height of the passengers above the ground 2 seconds after they pass the point on the wheel closest to the ground. Okay, so let's see what we can do with this. There's an image that we have right here to go ahead and kind of recreate what we're seeing. So it's telling us that there's a circle with a diameter of 128 feet. So here's my circle with a diameter of 128 feet. If it has a diameter of 128 feet, that also means it has a radius of 64 feet. And it sits on an 8-foot tall platform. So that's what this little box is here, that would be that 8-foot tall platform that this Ferris wheel is sitting on top of. So having a visual really makes this a lot easier. Okay. Now, it also says that the riders are sitting on the edge of the circle. Okay. And they're going around the circle as it's going. And we're trying to find the height of the passengers above the ground T seconds after they pass the point on the wheel closest to the ground. So that's saying right here, this would be that point where it's closest to the ground. That would be this point right here. Okay. And so what we're trying to do is we're trying to find a graph or an equation, essentially, of this going all the way around. And as that point goes up, okay, as we're going up, that's going to be our maximum, and down here would be the minimum. Now, you see this point right here never actually goes down into this 8 feet. That's just our displacement. We've just been raised up that 8 feet, whereas before previously, it would have been 8 feet below, and this would have been touching right on the x-axis. But instead, now it's been lifted 8 feet up. That is significant because that does actually come into play over here for midline. But let's go ahead and consider what we have here, amplitude. When you're talking in real world context, amplitude, if you're given a radius, it's going to be whatever your radius is. Amplitude is how far above and below are we going in the center of this circle. So it's the center of the circle that I'm considering here. So it's never going to go outside of it or above or below. So my amplitude here would just be plain old 64. Then I can go ahead and figure out what all the other information would be. Now we can figure out the midline. Midline is going to go ahead and be where the center of the Ferris wheel in this case would be. It's where the center of rotation is. So that would be right here, straight through this middle part here. So if you kind of consider what you have here, well, that middle part, that center of rotation, that's what we have for that midline. That's if I have my x-axis, if that's what this is, if I go ahead and draw, here's that x-axis, and then I've got my values right here. This is my y-axis, if you want to consider it that way. Then this point right here would be 64 plus 8. Well, that's why the midline then is going to be y equals 72. Okay. So now we've got that information, and now I can go ahead and figure out what the period is. Now, the period is going to be 2 pi over b. And so we've kind of got to figure out what that's going to be. We also know here, it does tell me that, where does it say? Just got to find where it is in the question. It completes one revolution every 60 seconds. So one revolution every 60 seconds. So we have that information in here. And so what we're going to need to do with that is we need to kind of consider that that's going to be our period, would just be 60. So now that I know that the period is 60 seconds, then I can figure out what B is. If you recall, my period, so period is equal to 2 pi over B. Well, we just don't know what B is, but we know the period is 60. And so we can set that equal to 2 pi and divide by B, and now we can solve for B. And in order to solve for B, remember I would bring B over to the other side, multiply both sides by B, that gets it out of the denominator, and now I have 60B is equal to 2 pi. And then in order to get B by itself, we would just divide both sides by 60. And so that gives me B is equal to 2 pi over 60. And that would reduce to pi over 30. So I'm going to write that information right there. So B equals pi over 30. And then now what we need to do is we need to kind of determine whether or not it's sine or cosine. So here's what I'm going to suggest we do is let's kind of unravel the Ferris wheel, if you will. So I'm going to go ahead and I'm going to draw a little horizontal thing here. And go ahead and give myself my little y-axis. And I would say that this right here would be that 8 feet for the bottom of my Ferris wheel, right? And then I'm going to have my maximum, which would be up here, which would be the 120. Oh, sorry. No, not 128. There's too many. 36. Because that 8 feet right there, the reason I'm doing that is because that's going to represent this bottom part of the Ferris wheel right here. And the 136 is the maximum of height of my Ferris wheel. So what I'm doing is I'm just kind of marking my y-axis so you guys can kind of see that that's where my graph is going to kind of oscillate. And so then I have to consider what it says right here. It says that this is going to be, it describes the height of the passengers above the ground t seconds after they pass the point on the wheel closest to the ground. So as they pass the point closest to the wheel, or on the wheel closest to the ground right here, so this little spot right here that's highlighted here in the bottom of my circle, that's the starting point. And then we want to figure out the height of the passenger as we're going around the circle. So you see it's going to go up to a maximum and then come back down to this spot right here. Okay, so let's draw that. So that initial spot, that very first thing when we're starting, when time is 0, we're down here at the lowest spot. And then we're going to go up to that midpoint, then we're going to go up to the maximum, then come down, and then be back here. And we could even go so far as to go ahead and label the x-axis if we really wanted to. I mean, I know the period is 60 seconds, so this would be 60, right? And this would even be 30, because that's halfway. Here's 15 seconds. Here's 45 seconds. Is any of that necessary? No, it's not, but I'm just kind of giving you some sort of frame of reference to try and help you understand. So now I can go ahead and look at this. Now I have this visual. This should help me a lot to determine whether or not this is going to be sine or cosine. Now remember, sine starts where? On the midline. Cosine starts either at the maximum or the minimum. The question is whether or not it's the maximum because it has a positive a, or the minimum because it has a negative a. And so I can see that right here that this is going to be a cosine function because it's starting at the minimum. So I've got cosine. Does it have a reflection? Yes. The reason I know it has a reflection is because cosine, the parent function, normally goes like this. But we've just taken it and we've flipped it right on over my x-axis. We've reflected it across the x-axis, so we have a reflection. Does it have a phase shift? It does not, because this minimum right here, the very lowest point, is starting right here on the y-axis. We would have a phase shift if, for example, if I was trying to write cosine, but I actually had the minimum not on the y-axis or the maximum not on the y-axis, and I was trying to do that, meaning I was starting from somewhere over there. I could write this as a cosine with a reflection if I wanted to start here, but that would be with a phase shift where I've moved right 30. That's it. Now, there's an infinite number of ways you can write the same exact equation, to be honest, because they're just phase shifts of one another. That's it. So let's go ahead and no, there's no phase shift. Let's write the equation. So we have y equals, and remember, the way to write these equations, I'm going to write it here, y equals a, and then it's going to be either sine or cosine. So in this case, cosine, b, x plus h plus k. So I'm going to go ahead and fill this in. So a is amplitude. So this is going to be y equals 64. But keep in mind I have a reflection. So because I have a reflection, it's a negative 64. So negative 64 cosine. B. We found b is pi over 30. So this is pi over 30. X plus h. Well, I don't have a phase shift, so there's no h. And because we're talking about time and trying to be in context here, I'm going to say just t. Okay, and then plus k. K, whatever you have for k, remember that's going to be whatever your midline is. So this is going to be plus 72. Now I have the equation. And that should go ahead and get me everything I need for this one. Let's try number 2. In Canada's Wonderland Amusement Park, there's a roller coaster that is a continuous series of identical hills that are 18 meters high from ground level. The platform to get onto the ride is on top of the first hill. It takes 3 seconds for the roller coaster to reach the bottom of the hill, which is 2 meters above the ground. Write a sinusoidal function to model the roller coaster's motion. Here's an image of exactly this. So you can see right here, it tells us that there's the hills are 18 meters high from the ground level. So if we go from ground level here at 0, we go up to 18 meters. That's our peak of the hill here. The platform to get onto the ride is on top of the first hill. It takes 3 seconds for the roller coaster to reach the bottom of the hill. So we're starting at the top of the hill, and then we're going to go down to the bottom of the hill, which is 2 meters above the ground. So that's why this is 2 meters right here. So this little 2 meters here doesn't even affect it. And then we're going to go back up right here. So it took 3 seconds to go from this maximum down to this minimum, and that's why this is 3 seconds here. And then 6 seconds then would be where we hit our maximum peak over here. Okay, so it told us in here what half of a period is. If I went from the maximum to the minimum, that's half of my period. And that's what it told me when it said that it takes 3 seconds for the coaster to reach the bottom of the hill, since we started at the top of the hill. And the reason we know that we started at the top is because the platform to get on the ride is on top of the first hill. So all of that stuff within that problem is really important to kind of take in and draw a picture as you're going through what you have, okay? So now we can go ahead and identify all of the information that we have here. All right, amplitude. Again, amplitude is going to be the distance from the midline all the way up to my maximum, or from the midline all the way to the minimum. So what's 18 minus 10? 8. So my amplitude is 8. That's the distance right here from this midline up to this maximum right here. That is 8 feet. Should probably use the units because they provide units in the question. Oh, I said feet and it's meters. Some things never change, y'all. I'll always make mistakes. All right. So then we've got that. Then the midline. So midline right here is going to be, in this case, how high up has our graph been shifted? So if I consider the middle of my entire graph that I'm looking at here, this whole graph, the middle is right here, right? We can see this whole section right here is going to be that middle of the actual graph part. And then the midline is how far have we been displaced to get there from the x-axis. So if my x-axis is right here and I've been displaced to this, I've been displaced up 10. So this is 10. And then the period, well, we already established that the period is actually going to be 6 seconds because if we started at 0 seconds at the maximum, took 3 seconds to get to the bottom of the hill, and then it's periodic, and it's going to go ahead and tell me that it's going to go ahead and be back up at the maximum in an equal amount of time it took for it to get to the minimum, that's going to be 6 seconds. So I can solve for b by saying I've got 2 pi over b, and that's equal to 6. So if you haven't noticed, you swap the b and the 6, and you get b is equal to 2 pi over 6. And that's going to reduce down, and that's going to get me b is equal to pi over 3. So now is this sine or cosine? Well, it looks like it's cosine to me. I mean, it doesn't get much more apparent that that would be cosine. I'm starting at a maximum, going to a minimum, coming back up to another maximum. So that's going to be cosine. And does it have a reflection? No, it's starting at a maximum. That's exactly where cosine is supposed to start, so it's good there. Phase shift. Nope, does not have phase shift. So now I can go ahead and I can write my equation. So we have y equals, and then it's going to be a, so 8. It's not a negative 8 because there's no reflection. And then we decided that's cosine. B, so b is pi over 3, times x. There's no phase shift, so it's just pi over 3x. And then plus k, which is my midline, so plus 10. All right, let's try this next one. So it says that Sam is riding his bike home from school one day and picks up a nail in his tire. The nail hits the ground every 2 seconds and reaches a maximum height of 48 centimeters. Assume the tire does not deflate. It totally would. Write a sinusoidal function that describes the motion of the nail as time passes. All right, so let's kind of consider what this is saying here. Let's draw a picture. So if I went ahead and did this, oop, no. All right, so basically what's happening is if that nail is going to hit the ground every 2 seconds, right? It's hitting the ground, so it's going to hit the very bottom. So I don't have anything that's being lifting my graph up or anything like that. So then I can just go ahead and start drawing on my y-axis. So the maximum height is 48 centimeters. So that would be 48 right here. That minimum would be the 0. And so then the midline would be 24, halfway in between. So that goes ahead and gets me this. And then now I have to kind of consider everything else. So I need to talk about the motion of the nail as time passes. Okay, and so we're going to talk about what we do know. We know that the nail, as every single time as it's hitting the ground. So I'm going to start with where it's hitting the ground, right here. Okay. And then I know then that every 2 seconds, it's going to hit the ground again. So then that means that in half a second, it's up here, 24 centimeters. Then at 1 second, it's up here at my maximum at 48 centimeters. Then at 3/4 of a second, it's here at 24, which is going to be that midline. And then after a full 2 seconds, it's come back to it and it's down on the ground again. So this is what I've got. So here's my visual of my graph, if you will. So right here, this is 1 second, and here is 2 seconds. Okay, so with that, we can go ahead and figure out our amplitude. So amplitude. Okay, amplitude is again the distance from this midline all the way up to the maximum. And so that's going to be 24. And then now I can go ahead and find what the midline is. And the midline right here is very apparent. It's going to be that 24 because again, it's that halfway point, halfway between the maximum and the minimum of the graph itself. And so that's going to be y equals 24. The period, well, we've already established that that's 2 seconds, right? So then that means that b, 2 pi over b, is equal to 2 seconds. We swap those b and the 2, so we end up with b is equal to pi, because the 2's will cancel out. So b is equal to pi. Then now we need to determine if this is sine or cosine. It seems like a lot of these are cosine. And I can go ahead and say that that is what we have right here for this one because we're starting at a minimum point. We are not starting in the middle. Does it have a reflection? Well, if it's cosine, yes, it does. And I can tell it does because it's starting at a minimum. Whereas if it was not with a reflection, it would have started at a maximum up there at 48. Phase shift, no. It does not shift left or right because the minimum is right there on the y-axis. So now I can go ahead and create the equation. So y equals amplitude. It's going to be the a, so then it's going to be negative 24. So I've got the reflection, that makes it negative. 24 is my a. And then we determine this is cosine. And then it's b, so that's pi times t. Now we don't have a phase shift, so there's no h. And the midline, 24, is exactly what I'm going to add here at the end, plus 24. Okay, so that should go ahead and get you through these. The rest of these problems, what I'd like you to do is I'd like you to work on them with a partner. I'll put the answers in your Canvas, and this way you guys can kind of talk yourselves through them, kind of check each other, and make sure that you've got it. Okay?